The finite element method is a numerical method for solving partial differential equations. This program uses that method to solve heat transfer problems in 2 dimensions. The user defines the geometry, thermal conductivity, and heat generation rate, and they can vary element by element, but are constant within an element. The user also specifies the temperature boundary conditions. The mesh uses triangular elements, and the mesh is entered graphically. We first define the grid, specify the properties, specify the boundary conditions, the computer solves, and then we can either list the solution or show a graphical representation of the solution. We use the JKL keys. Move left with J. It says right for K, but it's actually right for L, up for I, and down for K. When the cursor is in the desired position, depress the S key. We won't load the grid from the disk. We take that as the first point, and then we move over, or move over for the second point, up for the third one, and we want to enter another element. Move to the right, and then down. Let's refine the mesh. We'll refine element 1. Let's refine the mesh again. We'll refine element 2. And now let's prepare the solution. We have to enter the X and Y values for the grid. And so the first value is the lower right hand corner. We'll take that X equals 1. And we move over to the left corner. Take that X equal to 0. Then we'll move, we'll call that Y value equal to 0 too. And then we'll move up and call that 0.8. We'll make them the same for all elements. Thermal conductivity of 2, rate of heat generation of 3, just for fun. We don't want to save it. We have to enter the boundary conditions by specifying temperature at certain points. Okay, temperature at the lower right point, I'll set that as 0. At the upper left point, I'll set that as 1. The right point, I won't set that as anything. Nothing at the interior points. Now it's going to solve the problem. It will take about 9 seconds. We will draw the solution. Finding the border takes about 6 seconds. What contour do you want? Let's take 0.5. Draw another contour. Let's take 0.25. And we'll draw another one. .75. It's an unusual solution, but probably because of the boundary conditions that I picked. We don't want to do another contour, but that's what the solution is, going from 1 up here down to 0. Don't want to save it to the disk. And we could have listed the solution too, just like we listed the grid points. Those are the nodal coordinates. This is the element array. And this is the finite element mesh I've set up. This solution will take 141 seconds. These are the contours of the solution, going from 1, 2, 3, 4 up to 8. Do want to continue. Let's list the solution. And there are the actual values at each of the points.